Hello, good day to all. Before we're going to continue with our tutorial, let me remind you first on how you can access or get your work exercise for this chapter 2 hydrocarbon compounds of the organic chemistry is that you are going to send your $1 first to my PayPal account, after which send me an email that you did it so, and then I'm going to send your work exercise in a form of test paper right away. Alright, let us now proceed to our tutorial. Now to the continuation of our tutorial for our chapter 2 of the hydrogen carbon compounds. That the hydrogen carbon compounds has two subclassifications. What are those? The saturated hydrocarbon compounds and the unsaturated hydrocarbon compounds. What is a saturated? Saturated hydrocarbon compounds bears with a single band, while your unsaturated has a multiple bands, for example, double or triple bands. Your unsaturated hydrocarbon compounds has two subclassifications. Those were the aliphatic saturated hydrocarbon compounds and the aromatic saturated hydrocarbon compounds. What is the difference with the aliphatic saturated hydrocarbon compounds is that the aliphatic saturated hydrocarbon compounds has the open chain structure, while your aromatic saturated hydrocarbon compounds is a closed ring structure. Now, today we are going to talk about unsaturated hydrocarbon compounds. First is the aliphatic, meaning open chain structure, and the first compound is the alkenes. What is an alkene? Is that alkene unsaturated hydrocarbon compounds is again under with unsaturated hydrocarbon compounds bears with the double bonds between the carbon atoms. And if we could still recall our discussion in our chapter 1, that the general formula for the alkenes is CnH2n, and alkenes is also known as an olefins. What is an olefins? Is an oil former, also named olefin, also named as an ethylene series. Now we have three systems of nomenclature on how we can name the formula for an alkene hydrocarbon compounds or unsaturated hydrocarbon compounds. Those are the common system of nomenclature, the derived system, also known as, or an ethylene system series, and then the last one is the Aopaq system of nomenclature. What is an Aopaq? Meaning of an Aopaq? Meaning of an Aopaq is International Union of Pure and Applied Chemistry. Okay, now let us talk about the common system of nomenclature on naming of the alkene hydrocarbon, unsaturated hydrocarbon compounds. The first rule is that the alkyl group name first and then plus the suffix "ne", and then use a Greek letters to indicate possession of the double band. So we have this as our example. Name first the alkyl group plus the name of the Ne and use that first. Okay, here and is an example. This is our mother chain, the longest continuous chain of our carbon atom with the presence of the double bond. So meaning this is an alkene compound. So and then locate the position of your double band, which this double band is attached to an end, nearest to an end. So therefore this is nearest to this end compared to the other end, right? Therefore this double band is, we're going to assign our first carbon atom into this end. So this is our first carbon atom, then followed it through until to the end. And since this double band, which one is that you are going to consider? This double bond is being attached to the first or to the second? Of course, we are going to consider based on the rule that the double bond must be on the lowest number of the carbon atom. So 1 is lower than compared to the 2, right? So therefore 1 represents in the Greek letter alpha, 2 represents in the Greek letter beta, and then so on. So to name this structure, it is alpha. Why? The double bond is attached to the first carbon atom. Why but as a prefix of our name of our parent chain? Is because the total number of the carbon atom present in the structure, we have 4 carbon atoms, so the prefix is but. And YLNE in the common name system we are going to use because alkenes is also named as an ethylene, right? So therefore we have the suffix YLNE as butylene, the name under the common name system. Remember, we have 3 system of nomenclatures: common, derived, and Aopaq. Under common name suffixes, always we have the YLENE, prefix but for having 4 carbon atoms. YLNE meaning common name must bear with the suffix YLENE. Another example that I have for this structure is this. Okay, So if we have this, how many total of carbon atoms? We have 5. And the double bond is attached to the second carbon atom. Why second carbon atom? Because the double bond is near to this end compared to the other end. So therefore, to assign our number of carbon atoms, our first carbon atom is into this sign. So 1, and then continue assigning them until the other end. So since your double bond into this structure is attached to the second carbon and under the Greek letter it represents the beta, that's why to name this structure is called beta, meaning the double bond is attached to the second carbon atom, and then dash followed by the prefix pent. Why pent is because the total number of carbon atom of our longest continuous chain of the carbon atom for our parent chain or the mother chain has 5, so therefore the prefix is pent, and then a common in system you have to bear the suffix yl in e. So that's why we have to name this structure as beta pentylene. Now I have another name for this one. I keep recording this chapter because I keep on having this somebody send me a message that we have hurricane or whatever at this time. Okay, so much for that. So I have this other naming here. Alright, this is for the second part, the derived system of nomenclature. What are the rules of the derived system of nomenclature? The name of the alkene hydrocarbon compounds. First rule is that the compound is taken as derivative of ethylene. So therefore, the name of our mother chain, no other name, always bears with the suffixes of the word ethylene for the name of our alkene hydrocarbon compounds. If we are going to be asked to name the structure under derived system of nomenclature for an alkene unsaturated hydrocarbon compounds, always use this suffix, the word ethylene. Derive alkene, suffix is ethylene. Okay, that's the first rule. Then the groups attached to the ethylene group are named according to alkyl radical naming arranged alphabetically. So this is what I mean. So into this given example, in the first rule, you're going to locate the ethylene structure. What is the ethylene structure? Eth, the prefix word eth, meaning bears 2 carbon atom. While in E, so you have the double bond there. So a carbon atom that bears a double bond is automatic your parent chain, your ethylene name of the parent chain. Now the structures that attach to this parent chain are your alkyl radicals. So and then if you have 2 alkyl radicals present to the structure, in this case we have 2. Why? Because your ethylene is at the center of this this longest continuation of the carbon atom. So all you have to do is separate those, only take the structure with 2 carbon atoms that has a double bond, and the rest are your alkyl radicals. And then if you have 2, in this case we have 2, so follow the alphabetical order. What is the name of this alkyl radical that attached to ethylene, your mother chain? Yes, ethyl. And what about the other one that attached to this ethylene mother chain? Yes, methyl. So me and the E in the alphabetical order, A comes first compared to the me. So therefore, to name the structure under derived system of nomenclature, we have ethyl for this one, dash methyl for the next alkyl radical that attached to our parent chain, ethylene. So ethyl, methyl, ethylene. Alright, that is the rule for the naming of our alkenes under derived system of nomenclature. So this is another example for that derived system of nomenclature and how to name the alkene hydrocarbon compounds, unsaturated hydrocarbon compounds. This is a simple one, that your ethylene parent chain or the mother chain is into this end, and therefore there's no other no matter if you're going to extend the number of carbon atoms attached to this one, still we have only 1 alkyl radical that attached to our parent or mother chain, which is the ethylene. And in this case, we have this having only 2 carbon atoms. What is that name of alkyl radical that has 2 carbon atoms? Is it. The prefix is it from the word alkyl, the suffix is yl. So we have ethyl, and then plus the name of the mother chain, ethylene. So ethyl, ethylene. That is the derived system of nomenclature. Now the second the third system of nomenclature for the alkene hydrocarbon compounds is the Aopaq system. And then the first rule for the Aopaq system is that you are going to look first the longest continuous chain of a carbon atom that contain a double band, and take that continuous chain of a carbon atom that has a double band as your parent structure. And then the suffix of it, instead of for having a total of 4 carbon atoms present in that structure, instead of in our alkane having a suffix of A and E, in this case for the alkene we will be using the suffix E and E. Now, okay, for example, we have this total number of carbon atom 1, 2, 3, 4. Okay, let us just have 4 because that's the only thing that can fit into our recording. All right, so okay, if we have 4, so the prefix is but, right? So if we have but, then take the suffix A and E, so that is butene. That is the name of our parent chain. So, but we're not done yet. But what I'm trying to tell you is the suffix 4 for having 4 carbon atoms, but, and then always be the suffix of E and E at the end. E and E there. Alright, so okay, that is the second rule. And then to indicate the presence of the double band, oh shoot, then sorry to all of this. Okay, hopefully we can finish this. Right. Now the second rule is that number the position with double band using only the lowest of the possible numbers. So let us say the double band is located into this side, right? So you have 2 double bands there. And then consider that location of double band at what end is nearest to. So since this is nearest to this end, therefore our first carbon atom is into this side. 1, 2, and then continue assigning your carbon atoms until to the other side of the end of your chain of a carbon atom. And then after that, possible. Then the third rule is branches and halogen substitution. Okay, that's for the next rule. But so for the second rule, let us finish this. Number the position. So what is the name of that carbon atom now? Let me go finish the structure, complete the structure. So you have 2 there, so we need only 2 more atoms of hydrogen atoms. So 1, 2, 3, so this is CH, 1, 2, so this is CH2, 1, 2, and this CH3. So what is the name of this structure? Can you see? Okay, you can see. The double bond is attached to the first carbon atom. Why first carbon atom? Because 1 is lower than or smaller than the number 2, right? So therefore your double bond always attached to the smaller number of the carbon atom, which is 1 in this case. So the name of the structure is 1-butene. That is under the second rule, okay? Now the next is the third rule of the Aopaq system of nomenclature is that branches and halogens substituents are named as the rules of alkanes. So we're going to go back with our alkane naming of system of nomenclature to name the alkene for this third rule. And what about for that example? We are going to put our branch here. Let us say our branch is the methyl group CH3. So therefore you have how many bands here? 1, 2, 3, 4. So that's only C there. Okay, so in the third, in the rules of the alkane. So how to name the structure now under the third rule of the Aopaq system of nomenclature for the alkene unsaturated hydrocarbon compound. So let us name the structure. First is that you're going to use the alkyl or substituent groups that attach to your parent chain as our prefixes, right? So this methyl group is attached to the second carbon atom of our parent chain, and that is why we have the name for the structure as 2. You cannot see. Okay, let me go up a little bit. So to name this structure, you have 2 dash the methyl group to methyl dash the location of your, for the parent chain now, the location of your double band 1 dash how many carbon atoms? Butene. Okay, so that is under the third rule of system of nomenclature under Aopaq system for the naming of your alkene unsaturated hydrocarbon compounds. And then the fourth rule is the cyclic compounds containing double bonds are called Cyclo Alkanes. So what differs here now is your suffix. If you have butene in the close ring structure, we will call this cyclobutene. Now, cyclobutene. Okay, for example, what structure that bears with a cyclobutene? If we have that and a double band is here, that one, so therefore our first carbon atom is 1, 2, 3, 4. So to name this structure, this is, can you see? 1, 2, that's cyclobutene. Why 1? Because this is the lowest. Which one is lowest? 1 or the 2? Of course 1. So 1 dash were prefix cyclo because you have close ring structure. Why butes? Because you have 4 carbon atom represents the 4 corners, and the suffix ene, it's because you have double band present to the structure. So 1 cyclobutane is the name for that structure. Now, next rule is the fifth rule, compounds with 2 or more double bonds. We have not only 1, just like this, 2 or more double bonds are given the suffix diene for having 2 double bonds present in the structure, triene for having 3 double bonds present in the structure, and then so on. Triene, tetraene. Okay, so I'm going to give you an example for that fifth rule, compounds with 2 or more double bonds. Okay, just have this. All right, now into this example you have 2 double bonds present to the structure. So at what end? Either way. Why? It's because these 2 are nearest the same location. Now you have at the same. This one is attached to the first if we're going to assign our first carbon atom in this side. And if you have our first carbon this side, is also again the first. So either side, if you're going to assign your first carbon atom here because of this double bond, it's okay. If you're going to assign your first carbon atom here because of this double bond, it's okay. Either way, the same name of your structure will come out, the same name, if you're going to assign your carbon atoms either side. So now we have this 1, 3. Why 1, 3? Because our double bond in this side, if we have considered this, that it attached to this side 1, and your double bond is this one, and the second double bond attached to the third carbon atom. So 1, you have 1 and 3, right? So 1, 3, buta. Why bute? Is because this longest continuation of the carbon atom has 4 carbon atoms, so bute. And then diene is because you have 2 double bonds present in the structure. So butadiene. Bute for having 4 carbon atoms. Adiene is for having 2 carbon atoms. What about if you have 3 carbon? If you have not adiene having carbon. Adiene meaning you have 2 double bonds present in the structure. What about if your structure has 3 double bonds? Yes, butatriene. If you have 3 double bonds present into the structure. All right, now I have another example, this one right here. What about this structure? This structure has plenty of branches and groups that attach to with one only double band. You see here you have only one double band but with different structures. So first rule is that you're going to locate the position of your double band, and at what end is nearest to this side. That's why our first carbon atom is into this side. So again, you have to consider the location of your double bond to name the structure under Aopaq system of nomenclature for the unsaturated hydrocarbon compounds alkene. Alright, so first your first carbon atom is into this end because of the location of your double bond, and then continue assigning your number of your carbon atoms, and then after that you can name the structure. So how many groups or branches that we have here? 1, 2, 3, 4. And then are they of the same? No, different. Why? Because you have chlorine there and the 3 other groups are methyl. It's okay. So but we have 2 different names, different groups, the chlorine and the methyl groups. So follow the alphabetical order. If they are just only methyl groups, then don't follow the alphabetical group. But this one, in this case, we have chlorine here that separates the methyl groups. So follow the alphabetical order as our prefix says. So the chlorine comes first in the alphabetical order compared to the methyl, right? So name the chlorine first, that it attached to what carbon atoms of your parent say the longest continuous chain of the carbon atom, the 6th carbon atom. So that's why you have the 6-chloro, that your chlorine is attached to the 6th carbon atom of your parent chain. 3, 4, 6, meaning that your methyl groups are attached to the 3rd, 4th, and the 6th of the carbon atom of your parent chain. Trimethyl, why tri? Because you have 3 methyl groups. Dash 2, why dash 2? Is because this is now the location of your double bond where it attached to for your parent name. And then dash hep, why? Because you have 7 carbon atoms, your longest continuous chain of carbon atoms as your parent chain, hept, that represents 7 carbon atom, hept. And then the suffix ene, meaning this is alkene under Aopaq system of nomenclature, so 2-heptene. Alright, so another example that I could give you for into the summary of the Aopaq system of nomenclature is you have the CH3, no, CH2. I can give that CH3 dash 1. Let's see, I have the double bond here, so that is 3, and I have a branch here, CH3, continue 1, 2, 3, 4, 1, 2, CH 1, 2, 3, 4, and then you have 1, 2, 3, 4, and then the CH3 there. What about if I have, let me see if I could give, not if, I can give you. Alright, so you have CH, double band, 1, 2, 3, and one another, so that's only C. And this is CH2, and this one is another Cl, and this is CH 1, 2, 3, 4, and CH3. Okay, now first is that we are going to assign the number of our carbon atoms, which end our double bond is nearest to. Now in this case, this double bond we have 1, 2, and in this case we have this double 1, 2. So meaning either of these 2 sides, right? But first we are going to consider our branches. Now is our branches: the methyl group and the chlorine group and the methyl group. So which one comes first in the alphabetical order? The chlorine compared to the methyl. Therefore, in the double bond case, we're going to consider which of those 2 is nearest into the end. They are all the same. Now, proceed to the next consideration. In the alphabetical order, which one comes first? It's the chlorine, right? So therefore, our first carbon atom is into this end. So therefore, our first carbon atom here, 2, 3, 4, 5, and 6. Okay, now let us name the structure after assigning the number of our carbon atoms. So what is the name of this structure? Let me check here. Yes, we have named the branches. First is chloro. So you have 3 dash chloro. 3 dash chloro dash the second group dash 5 dash methyl. You have 2 double bonds at what carbon atom numbers? Dash 2, comma, and the fourth dash. You have 2 double bonds. And how many? 6. Diene. Okay, hexadiene. Hexadiene. Okay, so that is the name of our structure. 3 chloro 5 methyl hexa. Alright, 3 chloro 5 methyl 2 4 hexadiene. So for we still have a lot of time. Okay, so I'll give you the preparation of an alkenes. The first preparation is you have the dehydration of an alcohol. At what degrees is at 16 to 175 degrees Celsius. For example, we have this example. What's the name of that alkyl group that is being heated? Is your ethyl group. At what temperature? Ethyl alcohol. That is an ethyl alcohol. What happened here? Why I could not get it through? So this one is an ethyl group, ethyl compound. Now I cannot use you. Sorry. So that is, this is ethyl alcohol. Alright. Now, being heated at what temperature? 160 degrees to 175. So this is 160, not 16. Okay. And will produce an end product of CH2, double bond, CH2. What is CH2? You have 2 carbon atoms. Eth. Having a double bond is E, either ethylene or 1 ethylene or 1 ethene. No? For those 3 systems of nomenclature for alkene, unsaturated hydrocarbon compounds. So we still have a lot of time. We can still continue continue with our discussion and about alkynes. Alkynes, this is the second unsaturated hydrocarbon compounds that I talk about under unsaturated. So what is an alkynes? Another part of your unsaturated hydrocarbon compounds, and the alkynes bears with a triple bond and also named as an ethylene series. What is the general formula? Is CnH2n minus 2. So what is the nomenclature in naming the formula of your alkynes, unsaturated hydrocarbon compounds? Those were used the same as with your alkenes. What are the rules that we used for the alkenes? Is the same thing as with the alkynes. We can kindly review them so that we don't lose much of our time in our tutorial here, okay? And also will help you understanding of it's not a spoon feeding. But anyway, I'm going to give you a lot of examples. And then what is the difference here with the alkenes? In our discussion right now for the alkynes is that in the alkenes our suffix is E and A. That is, I'm talking about Aopaq system of nomenclature. But for the alkynes our suffix is Y and E. Alright, it's used for the triple bond to locate the location of the triple bond. Now for example, in our common name system, the name, if we have this structure, 2 carbon atoms present, this having 2 carbon atoms, prefix is acet, no, having 2, this common name, and then YLNE as our prefix, no, suffix, as in ethylene series, right, known as the ethylene. This is only the smallest. We cannot have only 1 carbon atom because we must see 3 bonds, triple bonds present to the structure. So therefore acetylene is the smallest compound of our alkene unsaturated hydrocarbon compound. So we cannot name lower than the acetylene. This is our lowest alkyne unsaturated hydrocarbon compounds, the acetylene, under common name system. For the Aopaq, F meaning 2 carbon atoms, Y and E, this is our suffix right here. Same thing as with our alkene. With an Aopaq, in the alkene, the suffix is E and E. And here in this time with the alkynes, the suffix is Y and E. Now we have only two systems of nomenclature, the comonym system and the Aopaq system of nomenclature. Alright, so I think that we have to finish this one not with a reaction. I wish we could talk about the reaction of the alkynes, hopefully. So, but anyway, in the comonym system, the Aopaq name system, this is our example. In the comonym system, we have this alpha. Why alpha? Because the triple bond is attached to the first carbon atom. Pent is because we have 5 carbon atoms present into the structure of our mother chain. And the suffix is YLNE as an acetylene, the suffix. So alpha pentylene. Alpha meaning your ethylene, acetylene, not ethylene, is this alkene. Your acetylene is in this end. Your triple bond attached to the first carbon atom. Pent is you have 5 carbon atoms. In the derived name, propyl, aside from your 2 carbon atoms, which is your parent chain, is acetylene. Consider that as our alkyl radical. And how many total of alkyl radical? 1, 2, 3 is prop, having 3 carbon atoms. Prop, the prefix is prop. So that is alkyl radical propyl attached to your acetylene, your parent chain, in the derived system of nomenclature. So the name of this structure is propyl acetylene. Propyl alkyl radical acetylene, the name of the mother chain. In the Aopaq system of nomenclature, your triple bond is attached to the first carbon atom, so 1. Then pentyne, YNE is your suffix. Pent is having 5 carbon atoms present into the mother chain. Now in the chemical reaction, wish I could finish this one and tell that chemical reaction. Wow, no, we could not. So let me just separate the reaction, chemical reaction of the alkynes class, because it has a lot. Alright, so I see you in the next recording for the chemical reactions of aliphatic hydrocarbon compounds, aliphatic open chain structure of our unsaturated hydrocarbon compounds. Alright, be well and God bless. See you next video.